Linear regression. Demystifying the math with real-world examples. Linear regression, the workhorse of statistical analysis, unveils the linear relationships between variables in your data. Imagine tracing a trend line through scattered points. That's linear regression in action. But beyond the visualization, there's a beautiful mathematical dance hidden inside. Let's break it down, step by step, and then put it to the test on real-world data. The math behind the magic. Linear regression rests on the equation of a straight line, y equals mx plus b, where y is the dependent variable, the one you're trying to predict, e.g., house price. X is the independent variable, the one influencing y, e.g., house size. M is the slope, telling you how much y changes for a unit increase in x. B is the y-intercept, the value of y when x is 0. Our goal is to find the best fitting line for your data, minimizing the errors between the predicted y values and the actual ones. This involves calculating the coefficients. M, estimated using the least squares method, minimizing the sum of squared differences between predicted and actual y values. B, calculated as the average y value minus the average x multiplied by m. Putting theory into practice. Let's dive into real-world examples. 1. Predicting movie ratings. Imagine you have data on movie budgets and user ratings. Here's how you can use linear regression. Dependent variable, movie rating, y. Independent variable, movie budget, x. By analyzing the data, you might find a negative slope, m, meaning higher budgets, x, don't necessarily guarantee higher ratings, y. The intercept, b, would tell you the average rating for movies with zero budget. 2. Understanding housing prices. Now, let's predict house prices based on square footage. Dependent variable, house price, y. Independent variable, square footage, x. You might get a positive slope, m, indicating larger houses, x, generally sell for higher prices, y. The intercept, b, would represent the average price of houses with zero square footage, which, of course, wouldn't exist. Remember, linear regression assumes a linear relationship between variables. If the relationship is curved, other models might be more suitable. Data cleaning and feature engineering can significantly improve your model's accuracy. Interpretation is key. Analyzing the coefficients and evaluating the model's fit helps you understand the underlying relationships in your data. Linear regression, with its clean math and real-world applications, is a powerful tool to unlock insights from your data. So, go forth, explore, and let the lines reveal the stories hidden within. I hope this explanation keeps you safe and informed as you explore the fascinating world of linear regression.